Hi, welcome to a deep dive and demo of the duplocloud product. duplocloud is probably the industry's most comprehensive DevSecOps tool. We claim that it's a robot which can actually perform 90% of the DevSecOps functions. And if you see in this particular picture, we have split those functions into layers all the way starting from network infrastructure, application, and CI/CD. These are more like representative services, but again, the claim is that the bot can actually manage 90% of the configurations. Okay, so now let's actually get into the product and do a demo. So first, Duplo Cloud software installs in a customer's cloud account. It's not a hosted service. All the data, everything, including the software itself, it's actually installed in a VM. It's within in your cloud account. Nobody else has access to it. We offer it as a managed service with your permission, but at any point of time, you can actually cut our access off and keep it all within the virtual network. So this is in this particular demo, what you see is we have this software installed in our cloud account. So you log into it using your organization single sign-on. It can be your Google or Microsoft or any other standard IDP providers that we support. Okay, so what we are going to do in this particular demo is that we will actually go and craft an arbitrary application and see how without requiring much of the subject matter expertise, and we will see that how the robot actually performs the DevOps functions. And one of the key things that we want to emphasize is that there are no pre-baked template into the system. There is no pre-baked Terraform, CloudFormation, Ansible scripts which have already been written. We have not created any Kubernetes deployments or anything of that sort. All of that stuff is going to happen dynamically, and the inputs for or the use cases and the workflows can actually be arbitrary. Okay, so what does it mean? So how does it all work? Effectively, the software is basically a rules engine. So you may ask the software to create a set of configuration. Let's say you may ask for an EC2 instance and maybe get an RDS database and deploy a bunch of containers. There are only so many ways how you can actually do it. Now within Amazon and all the possible workflows, maybe you have 500,000 workflows, but still they are finite. They are finite in nature. So what we have essentially built is that we have taken all the subject matter expertise that is required to create these finite set of workflows and put it into a rules engine, and then added a state machine on top of it, and then basically based on the inputs it runs it through the rules. The bot runs it through the rules engine and goes and gets this implemented. So that's what we are going to do. So let's start by introducing you to the concept of a tenant. Tenant is a fundamental construct in this particular software. Tenant in technical terms is actually three things. One, tenant is a container of resources. You delete the tenant, all the resources within it go away. Tenant is a security boundary, meaning that all the resources within the tenant will have access to each other. And then the third thing is that tenant is an access control mechanism, meaning that you could actually have tenant one and have which is accessed by user 1 to 3. Another tenant could be accessed by user for another set of users, and then maybe there is an admin who can actually access all the various tenants and so on, right? So practically speaking, how is the tenant used? In smaller environments, in monolithics, tenant is like prod would be one tenant, dev would be another tenant, stage would be maybe another tenant. In a larger environment where there are like a lot of microservices, people could say that maybe, let's say, service analytics prod is one tenant, analytics QA is another tenant, front end prod is one tenant, front end dev is another tenant, and so on. So it's really a workspace, and the user can use it whichever way he wants. Okay. So you see, when we created this tenant, all that we did is that we basically gave a name for the tenant. This point of time, again, I'm kind of emphasizing, is that we have no idea what the user is going to create in this particular tenant. You'll see that based on whatever the user decides, behind the scenes, the bot is going to auto-generate the infrastructure. So we've created a tenant. Let's actually go ahead and add a user. Okay. So let's say I'm going to add this particular user, and then let's log out and log in as that particular user so that we can show you a scoped functionality, basically, right? Because different people would operate on different tenants and so on. So now I logged in as this particular user. And then I have I have access to this particular tenant. Okay, I'm not able to see any other tenant. Now what I'll do is that I'll basically go and start by creating a host. Let's say what I want to do is that I want to actually deploy an application. It's going to be a Docker container. And it needs an SQL database, maybe it needs an S3 bucket, and then maybe we could also that's what we want to go to deploy. And then we're going to look at a few other functions, like how do you do logging, monitoring, audit trail, how do we actually look at the SecOps compliance and all those aspects of it. So I'm going to basically go just type a name, give the name of a host, and then maybe if I want I can give a few more application specific parameters, like maybe I can save a disk space and so on, but that's about it. I'm basically going to say that I want to basically create this VM with this particular size, and that's about it, right? So I'm going to click on submit. Now in Amazon you cannot just go and create a host like this. You need to basically specify what is the IAM role, what is the security groups, what is the instance profile, and there's a whole bunch of things that you need to specify. Now in this particular case the user did not do it, and the admin also didn't do it, because the admin didn't even know what the user was going to do it. So then how did these configurations got generated? So effectively what happened is that when the user went and asked for a host, behind the scenes the rules engine ran. The rules engine said, okay, you're operating in this tenant, you need a host, tenant is a security boundary, and you are in Amazon. In Amazon, the security boundary is typically implemented using an IAM role, an instance profile, maybe a shared PEM key, and a bunch of other things. So do they exist? They don't. And then it'll automatically go and create them. And then it'll basically add the host to it. Similarly, when you add another host, let's say what it can do is that it'll basically use the existing one and then go for it, basically, right? So that way it'll create the host. Now when it actually creates the host, behind the scenes what it will do is that, well, the host needs to go and get added to Kubernetes cluster, a bunch of things have to happen. So it'll basically take care of all of those things behind the scenes. In fact, when the tenant was created, the bot automatically went and created a Kubernetes namespace, because that's like a security boundary, how you can basically implement that in Kubernetes. Okay, so then the user basically says, okay, I have my host and then I want to have a bucket, S3 bucket. He goes and says, okay, I want a bucket, and he says S3. Now basically you see the user doesn't have to get into the nuances of what we are talking about, but what we are trying to explain is that the user stays focused on the application and the bot is auto generating the infrastructure. So you created a host, you created a server, now a host, and you created an S3 bucket. Now when you created an S3 bucket, you're operating in this tenant, there are a set of servers, the servers are going to need access to the S3. Now in Amazon, access between servers and S3 is done by IAM policies. So what are those IAM policy, how they are supposed to be connected, all of that the bot will figure it out and he'll automatically latch them together. Then the user basically goes and says, well, I want a database. So let's say he says my demo1db, and then he gives some username, password, and then he says Azure, MySQL, and then he could choose Aurora or any other database, and then he can basically say, just give me the default encryption. And then he clicks on submit. Now again, the rules engine runs. The database is created behind the scenes. It basically, the bot now goes and says, okay, well, you're in this tenant, there are some servers, the server need access to the database. RDS and servers are connected not by IAM policies, they are actually connected by security groups, and then it will automatically go and punch in the right roles and then connect them together. So if you see, all the subject matter expertise of that typically people have is being codified into a rules engine, and while the user is focusing on his app, everything is basically automated and auto-generated behind the scenes, right? And that way you can go and create any arbitrary AWS service or a bunch of other things. And later in the demo, we'll also talk about how do you add a new service to the rules engine, for example. But you could, like right now, what I'm saying is that instead of S3 and RDS, you could have asked for a Lambda function, you could have asked for Elasticache, Memcache. There are like so many things. Okay, now what you want to do is that, let's say you want to now actually go and deploy an application. So I'm going to basically call it a website, and then I'm basically going to say okay, I want the image is going to be nginx, and then you can actually specify some environmental variables. And then this environmental variables, you can actually specify the database username, password, endpoint, and so on that you want. You would have gotten the endpoint when this database is ready. So you basically, just as an example, I'm going to basically say my user, and then I'm just going to go and click on, I can fix the spelling, and then I can click on submit. Now what the soft bot will do behind the scenes is that it will actually automatically convert this application specific requirements into a Kubernetes deployment, and then it will make the right set of API calls and put it in this particular namespace, and then basically it'll deploy it, right? So from a user's perspective, you basically really focus around the app. If you see this in this particular parameter, these are all very Docker specific stuff. Kubernetes as a container orchestration mechanism probably falls more in the DevOps world, whereas Docker is more about the application. So these are all Docker specific parameters basically. So you would basically specify them and it'll automatically get converted into Kubernetes parameters. Then the user says, well, I have my application, it'll probably get started. Now I want to expose it via load balancer. He basically says, I want to expose it via application load balancer. The port is port 20 is my app port. He says externally exposed via 443. He can choose it to be public facing. He says this is my health check, and then there'll be like a certificate provision like one time for the entire maybe a set of certificates for the organization. So he just chooses the certificate, and then this is usually done when you first install the bot based on the domain, and then you click on submit. It will automatically go and map it into Kubernetes constructs. It will basically create a node port, ingress, and all those complicated things that you need to do, right? So, so that's that. Now, what you might be thinking is that, well, at this point of time, it looks like an abstraction on top of AWS, on top of Kubernetes, but I really need to get to my AWS because as an engineer, I need to basically access my S3 bucket. I need to upload files, and maybe there are a bunch of things that I need to do. For example, I have this load balancer. There were only a few parameters that we had. I want to change the timeout and a bunch of things which are still application specific but which are available in AWS. So the way you can do it is that you would go over here and then you would actually click on this particular button. Any resource you can go this particular button. So basically every resource will have the console button, and then what it will, the bot will do is that the bot will dynamically generate an access for you into your AWS account and scope you within your specific resource and give you basically specific application specific logic. In fact, if you see, this is exactly what a human DevOps engineer would have done as well. In fact, just user access management is such a big problem. Like every time you have to go and get access, somebody will give you access and then they'll forget, they have to write IAM policies to scope your access, then they'll forget to take your access away and so forth. But in this particular case, you have access to the tenant using single sign-on. You would click on this button, it'll give you access to your console, and it's a just-in-time access. After a little bit of a time, it'll basically take your access away, right? So so that's that. So the fundamentally again, our goal is not to be to hide AWS from the user. Our goal is to basically just hide the DevOps specific nuances so that the engineers and the DevOps teams can actually focus on building the application and the product, while the standard rules based and best practices based cloud infrastructure and the DevOps are automatically taken care of. Now, similarly, just like AWS, let's say the user basically goes and says that, okay, he wants to actually dig deeper into Kubernetes if he really wants to. What he can do is that he can simply go and click this particular button. And what will happen is that it will actually set up kubectl for him and give him access. Now, it takes a little bit of a time to set up. So let's go out and go to a tenant where this is already set up. So all you have to do is basically click a button and then you'll get access to kubectl. Automatically all your Kubernetes permissions will be set to scope you within that particular within that particular namespace and so on. So for example, I'm in this particular tenant which I had set up before. You click on this button, you get kubectl. Now you can basically say kubectl get pods, and then it'll and then it'll basically show you the pods, right? So what we actually did just now is that, just a quick summary, we basically created a workspace. We went and went through an arbitrary workflow, which was basically to create a set of servers with a database, S3 bucket, and deployed an application. Underneath it was EKS actually was running, and all of this was done on AWS. Look at the metrics of this application. Now, if you go to Amazon and if you basically go and say, well, give me metrics for my demo application, Amazon would be like, what do you mean by demo? I don't understand demo. Tell me, what resources do you need metrics for? Half of the time, what you need to do is to figure out which application has what resources before even you can pull in the metrics. But in this particular case, what you can do is you can, within the tenant, you can actually click on metrics, and then what the bot will do is that the bot will look at all the resources that belong to this particular tenant or workspace, and it will give you effectively the metrics. Like, for example, this is giving you an ELB request count and whatnot. Now you go over there, maybe some of the servers are not really performing, you want to set an alarm, you can actually click on this, and then it will basically tell you, okay, you can set an alarm on this particular host. For example, you can set an alarm on this host and that host. And what the software will do is that it'll basically collect the alarms and automatically send a notification to you if things are going wrong. So effectively, again, what we are trying to basically do over here is that this is a DevOps bot which emulates a DevOps engineer and effectively puts together a whole bunch of DevOps tools underneath it. What tools does it put in? Based on the use case, it tries to use the maximum tools which are offered by the cloud provider itself, like Amazon or Azure and so on. That's the first priority. The second priority is the tool itself has a bunch of features. Okay, it'll try to use that, or it'll use open source, or it'll use the third party which the customer has to pay. So this is the priority order. So if you see, as of now, about 60 to 70% of the underneath functionalities are leveraged based out of the cloud provider itself. Maybe about 10 to 20% are natively built in the product itself, in addition to, of course, the product being the bot and the rules engine, which is the core part of it. And then finally, the third is basically we integrate with open source, and in some cases we actually integrate the customer with their tools. Okay, now we've seen the DevOps functions, and now let's look up a little bit about advanced security and SecOps functions, especially in the context of regulatory compliance like PCI, HIPAA, SOC 2, and so on. So while on the DevOps side we have been creating servers and the various different configurations, automatically there is actually a security modules which keeps an eye on all the changes that are happening into the system, and the net impact is that it actually goes and puts in all the controls automatically that are necessary in these systems. And the net effect is that if we basically go and click on compliance and the dashboard, we'll basically see tens of security controls which are in place basically. So let's look at that. So for example, this is the security dashboard which comes built into the system. Not just built into the system, as you make changes into the system from a DevOps side and infrastructure side, this system automatically keeps itself updated with that. For example, if we click on agents, you see we actually created new set of servers in demo 2. For example, so what we can do is we can click, you see that automatically the host was added without even clicking a single button. We automatically see that this particular system has been added into the security dashboard. You can click on the security events and it will basically tell you all the various things that are actually happening into this particular host. You can see that. You can look at the PCI dashboard. You can actually do more things, like for example, let's say we want to see policy monitoring. We can go and look at a bunch of things over there. It'll basically say anomaly detection. It has detected a particular anomaly which is present in the system. It can basically do configuration assessment, CIS benchmarks. You can actually see system auditing, or if you want to go beyond one VM and you want to look at a more broader level, like for example, it automatically integrates with various AWS security tools like guard duty, inspector, and so on. Like for example, if we look over here, there is a server which has Windows and somebody is probing it, for example, right? So it is saying unprotected probe is being probed and so on. So all of these systems have been lashed together automatically, as if there is a real SecOps engineer behind the scenes, right? So you see that if we actually if we go back to the picture about the capabilities of the software, you see we are basically showing a lot of these things. We covered the application infra layer, the network layer, the application, we saw the Kubernetes part, the load balancers part. Of course, we saw all the VMs, the databases and stuff. All along we are seeing the compliance controls into the system, right? So you see how comprehensive this particular system is, and how we are able to do it is by basically trying to emulate a DevOps engineer using a rules engine. Fine. Okay, now we have seen the core DevOps, we have seen the SecOps part of it, SecOps and compliance. We can actually switch gear and look at a little bit of CI/CD. Yeah. So the way the CI/CD portion of it works is that you basically go and click on CI/CD, and then under each tenant you can actually go and link your repositories basically, and these are the repository out of which you will basically deploy the services. So for example, under the deployment, these are the services that you have, and these services, let's say, come out of these particular repository. Like for example, I have a tenant in which I have actually added the repository. So what you would do is that let's go to this particular repository, and then let's try to see how we can make a particular code change in the repository and how it triggers CI/CD so that the configuration is rolled out. So I have this particular repository, it is linked to this particular tenant, the tenant is deployed. Let's see what do we have in the tenant. I'm going to take the DNS name, I'm going to try and see what do we have over here. So we have some information. Now if you go to this particular service, I'm now going to make a code change. So let's say, so this is actually what it has. So if you see over here, this is actually what it has. So what we're going to basically say is that let's make a code change and let's call it duplocloud deep dive CI/CD demo, for example. Right, so we make this particular change, demo, and then we'll basically commit. Now when we do that, what will happen is that the CI/CD module will automatically resist this particular change. You have this commit and you have this change, and now what you can do is you can click on this particular button, and what it would, and then basically decide to actually trigger a workflow. We'll probably not get into the details of the workflow. These are basically typical CI/CD workflows that you can generate. Like, I mean, if you look at GitLab or any other tool, people define workflows. So what you could do is that you could actually trigger a workflow. What Duplo is basically going to do is that Duplo has automatically has sort of this Jenkins in the CI/CD workflow built in. So what it will do is that when you trigger a build, Duplo will automatically go and deploy a dynamic build container basically. So what we are doing is that we're really doing build as a microservice. So we're going to trigger a build container, and in that build container, Duplo is going to check out the code, run the build, and once the build is over, the build container is going to be destroyed basically. Like for example, this is the build container, and then this particular build container will basically run the builds, and once the build is done, that build container would be deployed, and then for the next phase another build container will be launched, and then the tests will be run, and then it will be destroyed, and so on. But what is the net impact? The net impact is that once you have written your CI workflows, you can basically everything is integrated into the system. You can actually click a button, trigger a build, and basically after the builds are done, it will get deployed effectively. So you don't even have to set up Jenkins or anything of that sort. Duplo will automatically take care of it underneath the system. Now, if we go back and look at the servers, we see that the build is running. You want to look at the logs. So these are the logs. It's actually building stuff. So effectively what you are seeing over here is that this is actually building the application Docker container. So in some senses, we are doing Docker inside Docker. What does it mean? Basically, the build itself is running in a build Docker container, and inside the build Docker container, the CI code is actually building the application Docker container and pushing it. But so yeah, so the first phase was basically the build phase that is done, and now it is actually deploying. So what do you mean by deploying? If you look at the service over here, you will see that the image ID will actually change from this to the commit that we have actually made. So, and this particular commit was A23. So if you see over here, in just a few minutes, this will actually change. There you go. So the image is changing, and you see that the image is there is a deploy that is actually happening. The old container will go away, and then the new container will come up. And once that is up, we can actually go here, and then we can refresh, and then we'll see that okay, demo is done. So basically you see the CI/CD part of it. I mean, of course there are a lot of nuances about the CI/CD. What are workflows, like how do you create different workflows for different tenants, what are each steps of the workflow, and so on, but we'll skip that for the purpose of this demo. By the way, what you can actually also do is that you can use your existing CI tools, like for example you can have Jenkins, Azure DevOps, GitLab, and so on, and you can also point it to Duplo. So in that sense, I mean, it's not necessary that you have to use this particular CI/CD tool. Overall, I mean, in the Duplo Cloud picture, it's fairly a modular system. Basically, you can swap out the layer if you want to, and then you can bring in your own layer to actually do this. Each one of the layers can be swapped out, and then you can bring in your own tools and so forth. Okay. So that was that. I think in summary, what we kind of did is that we showed the capabilities of the tools across the stack, and showed you how comprehensive this particular software is, and effectively it can auto generate and auto create 90% of the configurations that people have to do it themselves.